All right, we're going to pick up where we left off on Friday. Depending on which class period you were in, we were at different places in this fourth example. So we're just going to start it again, and we'll finish it, and then we'll do the final example. Okay, the prism that's shown here has regular bases. The hemisphere has a great circle of 25 centimeters. Okay, now on Friday, we were able to define what this thing was. Okay, and this shape, we arrived at the conclusion that it was a triangular prism and a hemisphere. Okay, so our volume was going to be the result of a prism plus a hemisphere. Okay, now from that we would go to our formula charts, and we would see if we could find some formulas to go along with these guys. Okay, well, the one for prism we ought to be getting very familiar with. How do you find the volume for a prism? Yeah, so big B little h, that's right. Okay, big B little h for the prism. Okay. The hemisphere is a little bit tougher. All we have is a formula for an entire sphere. Okay. And the formula for the entire sphere is 4/3 pi r cubed. Okay, but we don't want the entire sphere, we just want hemisphere. Okay, so that's half of it. So it's going to force us to make a little bit of an adjustment to the formula that we have. We're going to divide by 2, or just take half. Okay. Now, this problem, as we were beginning to see on Friday, was a little bit not quite as nice as some of the other ones, because the information that we needed to plug into the formula, not everything was provided. Okay, so like first off here, when we were looking at big B, okay, well, our base, as it happens, is a triangle. Now it says that the prism has regular bases, so we are the same on all the sides of our bases, and we can see from our measurements in our figure that we had 10 units on the side of the base, so 10s all around. Okay. Well, in order to find the area of this base, well, our base is a triangle, so we're basically needing 1/2 times base times height. That's our formula for the area of a triangle. And then the rest of this is unchanged for the moment. Okay. The base and the height of the triangle, and that brought us to a little bit of a problem. Was that guy. We did not know the height of this base. But as y'all were so quickly able to point out, okay, you got Pythagorean Theorem in there. This 10 is split into 5 and 5. So you've got 5 as one of the legs of your little triangle in there. You got the height as another leg of the triangle, and you got 10 as the hypotenuse of the triangle. And we're able to solve it from there. 5 squared is 25. 10 squared is 100. We subtract the 25 to the other side. We end up with height squared equals 75. And then we don't want height squared, we just want height. So we would take the square root to get the square off of there. And our height is whatever square root of 75 is. Okay, so bringing that information to our problem, okay, B right there is the base of the base, okay, 10. H is the height of your base, which we just discovered was square root of 75. Okay, that's what was in the parentheses. And then the h that's sitting outside of the parentheses right there, that represents the height of the prism. Okay, the distance between the two bases. And as I believe y'all had already pointed out, the height was going to be 12. Okay. Then we go, okay, now what about the sphere? You got that half there, you've got that 4/3 there, you've got pi, and then radius cubed. Okay, well, we don't have the radius, and I think this is where this particular class was kind of ran out of time, was we were trying to figure out what was going on with the radius of the hemisphere. Now, the only information we had about the hemisphere was that it had a great circle of 25. Okay, so the great circle is 25. That's a circumference measurement. Circumference is 25. Okay. And what do we know about circumference? Well, circumference is 2 pi r. And they just said that the circumference is 25. So 25 is 2 pi r. Okay. Now, just like from the work that we did on spheres the other day, all we have to do is solve for the radius, and then you can use that information about the radius to plug in for any other formula that needs radius. Okay, so from here, we said, all right, I want to get the 2 and the pi away from the radius, so I'm going to divide both sides by 2. I'm going to divide both sides by pi, and that will give you, on the right side, the only thing that'll be left is the radius, and it will equal whatever 25 over 2 pi happens to be. Okay, so 25 over 2 pi. Now, what that means is this value, which is the radius, and I'm kind of out of space, but we need to cube it. Okay, you got 1/2 of 4/3 pi r cubed. Okay, now we got a formula there, very ugly formula, but we've got one. Okay, so what we probably want to do at this point is we want to come to our calculator and see if we can't get a little assistance. I'm going to do this in 2 different steps. I'm going to do the left side of the addition sign and then the right side of the addition sign, and then we'll combine them. Okay, what do we actually have on the left here? We've got 1/2. We've got times 10. We've got times the square root of 75. Be sure on your square roots, okay, depending on what kind of calculator you have, either when you press the square root, the radical button, it's going to open up some parentheses, put whatever you want underneath the radical, but then close the parentheses. Or in this calculator's case, you see how the radical, the bar over the top, keeps on extending? If I keep on typing, it's going to keep on extending. Okay, so we're going to need to tell the calculator where to quit putting stuff underneath the radical. Okay, so I'm going to delete all that extra junk there. Okay, so what you need to do is once you've gotten everything under the radical that you want under the radical, just press the right button one time, like you're trying to shift over one space. It'll shut off the radical, and now you can continue on with the problem. And also need to multiply that by 12. Okay, so 1/2 times 10 times square root of 75 times 12 is something in the ballpark of 519.62. That will need to be added to whatever's coming out of that hemisphere problem over there. Well, let's see what we got. We got 1/2. We've got 4/3. We've got pi. And we've got a fraction. 25 over 2 and also over pi. And that fraction needs to be raised to the 3rd power. Okay, remember how you raise something to a weird power? Use your little caret button right there on the right side, the little rooftop looking guy. And again, depending on which calculator version you have, either it will show you the little rooftop guy and then you can type your power, or it might possibly even shift into exponential notation like this one is, and you can just type your power. And again, once you're done with your power, it's actually the end of the problem. I don't have to worry about it here, but you can just hit the right button and it'll drop out of that exponent. Okay, so there should be everything I've got going on the right side, and that seems to be 100 or 1187.36. And you've got all the decimal points showing right there. So while I rounded them off to write them down, we ought to be able to get everything that we need here. That answer, 1187, I'm going to add it to 519.615. And you can put as many decimal points in there. You've got them both in front of you. Okay, but there we go. Looks like we got an answer of 1706.97. Okay, 1706.97. What? I don't know. Let's go back to the problem and see what the units of measurement were. They were centimeters. This is volume. So it's cubic centimeters. Okay, that's a lot, you know, as far as 1,706, but you got to realize a cubic centimeter is, you know, those cubes that we were playing with the other day, those are cubic centimeters, so it's 1,706 of those. Well, there's about 1,000 of them in that box. Okay, so while it's a big number, does it actually turn out being that much mass? No, it's pretty small. Okay, so there's the end of that one for wherever your particular class was when we left off. All right, there's one more problem I want us to look at, or one more problem that we had from the opening screen. So let's see if we can't figure out a volume to go with this figure. Now, while we're copying it, let's refresh our memories. What does it mean that we've got this kind of two-tone shading going on in there? Why, how come one part of the figure is a different color than another part? What's that mean to us? Now, we've got a cavity. We can see into the interior of the figure, whereas, you know, if it were completely solid, we wouldn't be able to really see into it at all. Okay. So, how is it that we describe this one? Okay. What is this thing? Okay. When we were going over it, we said it could be a cube minus a pyramid, or possibly a rectangular prism minus a pyramid. Okay. What do you think? Okay, can we answer the difference? Is it a cube minus a pyramid, or is it a rectangular prism minus a pyramid? Can we see the difference now? It is a cube. How do you know it's a cube? Yeah, if you observe the measurements that are in there, all three dimensions of this prism are the same. By definition, that is a cube. Okay, and that may actually be important. I could very easily see you know, end of course, instead of actually giving us a problem and making us calculate it, giving us a problem and making us describe it. Like maybe the four answer choices are descriptive rather than quantitative. It could be sentences. So we might have to find the description that actually matches the figure as best as can be. And maybe the most descriptive would be the difference between the language of being a cube or being a rectangular prism. Okay, so let's see if we can put some formulas to this. Okay, now a cube is a prism. That's how we got into that debate to begin with. So the formula for volume of a prism is still big B, little h. But since it's a cube, as y'all have already said, it means all three of the dimensions in the prism are identical. So that means that instead of saying big B little h would be base of the base times the height of the base times the height of the prism, we can simply say, hey, it's a cube, that's side cubed. How about the volume for a pyramid? How do you get that? 1/3 big B little h, exactly. Okay. Now let's see if we have everything that we need to solve it. Side of the cube. Do we know a side of the cube? Yeah, that's pretty much all we know, right? Okay, so we're going to end up with 23 cubed. That's going to be a rather large number here in a little bit. And from that, we're going to have to subtract 1/3 big B. Now we're looking at the pyramid. Okay, keep in mind the pyramid is in there upside down. Okay, how would we find the area of the base of our pyramid that's cut out? It's 23 squared, isn't it? I mean, in the base of the pyramid, it kind of consumes what would have been a side of the cube. Okay, so we're going to end up with 23 times 23 on big B, 23 squared. Okay. Yeah, now the height of the pyramid, okay, this is kind of a neatly engineered little problem that I put together here. But the height of the pyramid is, of course, the height is measuring, you know, from, you know, one edge or from one base all the way to the other base of that cube. And in which case that is this same 23. So kind of look what happened here. On one side of the problem, you got 23 cubed. What happened on the other side of the problem? You got a 23 cubed over there also. You got 23 squared plus 23 to the, or times 23 to the first. Laws of exponents, so you add those exponents up. So you got 23 cubed times 1/3 of 23 cubed. Okay, even if you didn't catch that, it's certainly fine. You can come to your calculator and let's get this thing one step at a time. 23 cubed is 12,167. And then you can go, okay, I've also got 1/3 of 23 cubed, which is 400 or 4,056. 55, and 0.6 repeating is just 2/3. And then we can subtract those away from each other. 12,167 minus the answer that I just got. That'll keep me from having to worry about all those decimal points. And we end up with 8,111. And what's 0.3 repeating? 1/3. There you go. Okay. The units of measure were millimeters. Volume is third dimensional. Cubic millimeters. 8,111 and a third cubic millimeters. Well, actually, if you were to break that down into simple terms, 8,111 cubic millimeters is actually less volume than the whatever it was, 1,800 cubic centimeters that we had a moment ago. So this figure is actually smaller in volume than the triangular prism in the hemisphere that we were looking at just a moment ago. So not a very big figure at all. Okay. Well, that's basically it, just like with the composite polygons that we worked on at the end of Unit 7, whatever it was. The examples are infinite. Okay, we could do these pretty much from now until the end of the year and never really even scratch the surface. So it's just going to take some practice. Okay, remember the most important thing about these is correctly identifying in plain English what the figure is, a prism plus a rectangle, or a prism plus a cone, or hemisphere plus a cone, or stuff like that. If you can correctly identify it in plain English, then apply the formulas to the English that you came up with, fit the numbers into the formulas, and get an answer. Okay, so that is all.